so now it's time to get back into actual doing real work. Now, ladies and gentlemen, I told you in the video yesterday as I went over all those problems that today we are going to be talking about t-scores. Okay, nothing changes in the problem except for instead of doing a z-score, we have to do a t-score, which means that our critical values are going to be the most important things to find. Now, what I'm going to do is I'm going to write the first problem. I'm only going to go over two problems, and then I'm going to give you problems to do, because hopefully by the time that you've seen this, you've got the feel for what we're doing. So let me write up the first problem, and then we'll go through it together. All right, so here we go. You wish to test and see if the Pepsi-Cola company is not filling its 16-ounce bottles all the way. You buy 18 random bottles and find your sample to only have a mean of 15.8 ounces with a standard deviation of 0.4 ounces. At alpha equals 0.05, can you say you're being cheated? Now, a couple of important things. Your sample only has a mean, so this is a sample mean and a sample standard deviation of 0.4 ounces. This is not a population standard deviation. This is a sample standard deviation, which means we need to use a what? A t-test. That is why this is a t-test, not a z-test. All right, so start off with the conditions. Okay, SRS. You bought 18 random bottles, so that is given. Okay. Independence. Okay. Population greater than 180. Is there more than 180 Pepsi bottles out there? Yeah. And then normality. N greater than or equal to 30. Well, we only did it 18. So we have to what? Assume. There's nothing in the problem that says it is normal, so we have to assume. Okay, so our conditions have been taken care of. Now, what is our null hypothesis? Our null would say that mu is greater than or equal to 16. Our alternative, because we feel that we're being cheated, would say that mu is less than 16. Again, where's the equal? It's always in the HL. What is our claim? Well, our claim is HI. We feel that we're being cheated, so we're going to say that that's our claim. All right, now, very important, critical values. Okay. This is a one-tailed test on the left-hand side because we're doing less than. Alpha is 0.05. Oops, starting to write my name. Alpha is equal to 0.05. Degrees of freedom is equal to 17. Where did I get that from? Well, n is 18. Degrees of freedom is 1 minus n. This is one-tailed test, so all we have to do, we can go to the 0.05 on our table C on our blue chart, go down to 17, and we end up with 1.740. But since it is a left-tailed test, that is a negative 1.740. Please don't forget to make that distinction. All right. Now, we find our t-score the exact same way we find the z-score, right? Observed minus expected. What was observed? 15.8. What's expected? 16. Divided by the standard deviation of 0.4 over the square root of 18. So our t-score ends up being negative 2.12. All right, what is our decision, guys? Is negative 2.12 in our critical zone? Yes, so we are going to reject the null. Now we aren't done yet, okay? So I've got to go and write my conclusion. Okay. We rejected the null. So if we reject the null, that means therefore what? We do or do not have enough evidence. Reject, we do have enough evidence. Fail to reject, we don't. So therefore, we have enough evidence at alpha equals 0.05, 2. Now remember, was our claim HO or HI? Our claim was HI, so what word do we always put if our claim is HI? We reject the ho and support the high, so we are supporting to support. And what was our claim? Pepsi is not filling its 16-ounce bottles by Coke instead. Now, obviously, you wouldn't write that, but I just thought that would be like, maybe you'll get a nice little chuckle and a nice little smile out of that. All right, so that's the first of the two problems today. Make sense? As I said, this particular part of stats is very repetitive. If you get it straight the first time, it's really easy. Those of you that already have A's, it's going to be really hard for you to get below an A anymore because it's the same thing over and over and over. Just keep yourself straight. All right, let me erase this, and I'm going to go ahead and write the next problem. Okay, so we have a claim by the Walkersville Fire Department. It says it responds in at most 10 minutes. Random sample of 30 calls found a mean of 10.6 minutes with a standard deviation of 2.9 minutes. Test their claim at alpha equals 0.01. Okay, first things first. Conditions. SRS. It says a random sample, so that's given. Please don't put assume. That's given. Independence. Do we have a population greater than 300? So do you think they go on more than 300 calls? Yeah, I think so. And then normality. Is n greater than or equal to 30? Well, we've got 30 equal 30. So are we good with normality? Yes. All right. So, again, the main thing that you have to understand is why this is a t-test. Okay, we have 30 calls. We have a mean of those calls of 10.6, and the standard deviation is of those calls. Okay, so that means it is a sample standard deviation. So that means we are doing a t-test. All right. So let's look at HO and HI. HO would be mu is less than or equal to 10. Okay. At most 10 minutes. Okay. If it means at most of 10 minutes, that means it can be less than 10 minutes, but can't be more than 10 minutes. So HO is less than or equal to 10. And the alternative hypothesis, HI, would be mu is greater than 10. What's the claim? The claim is HO because it says it responds in at most 10 minutes. Okay. Now, this is a one-tailed test, always based on HI. HI says greater than, so this is greater than. Please do not, because the claim is on HO, do not assume that you test based on HO. It's always on HI. So you're going to have HI. You're going to do this. What's our degrees of freedom is 29, and alpha was 0.01. So we go to our chart, find 0.01, go down to 29 degrees of freedom, and that looks to me like it should be 2.462. So my critical value is 2.462. T-test, which exactly like the Z-test, observed. What was observed? 10.6 minus the expected of 10 divided by the standard deviation, which was 2.9, over the square root of 30. So we have a t-score of 1.13. So that's somewhere around here. Call this 1.13. So, reject or fail to reject? Is it in the shaded in area? No. So then we fail to reject. Fail to reject the null. Okay, not done yet. We still have to write our conclusion. Again, it is so formulaic, guys. We failed to reject. Therefore, if we fail to reject the null, that means we didn't have enough evidence to reject it, so we do not have enough evidence. At alpha equals 0.012. What word goes after 2? It's either support or reject. What's the claim? The claim is HO. If HO is the claim, then we reject the ho, support the high. So this is to reject. To reject that the WFD, Walkersville Fire Department, responds in no more than 10 minutes. Okay. We do not have enough evidence at alpha equals 0.01 to reject that the Walkersville Fire Department responds in no more than 10 minutes. So, again, guys, you start trying to wordsmith this, it's going to mess with you. Okay? Use the formula. It's very straightforward. You won't get it wrong if you do it that way. All right, so there's that. Much shorter than yesterday. I'm going to give you several problems tomorrow to work on, and we'll go from there. Enjoy your afternoon.